today we're going to create the mesh for the rope that I did in a previous episode. If you haven't watched it, I guess I can put it somewhere there or there, maybe. I don't know. Can't really point in this camera. But the process of generating the mesh for the rope is that we need to generate all the vertices that will be connecting the start to end. They will be like in a circle around each segment that we created. After that, we need to update them every frame so they get a new position. Then we need to connect them with faces, mesh faces. A face is consists of 3 vertices, and we need to connect them in the correct order so we get the normals on the outside. Otherwise, it will look strange, inverted. And then we will connect it all to a mesh render so we can see the mesh in Unity. Yep, let's get started. There's been some some storm regarding Unity lately regarding their runtime fee. I will not go into that. I guess you have already heard of it and make up your mind if you're staying or leaving. For now, I'm staying with Unity and plan to do a bunch of Unity videos from now on as well. As you can see, this is kind of the same scene as we left off in the previous video. And you can see that I have a rope that's interacting with this little box. So we will try to recreate this mesh today. So what do we need to do? We need to, let's deactivate that, jump into the wire C# file that we had before in the previous as well. So if you haven't seen that video, please check that out first if you like to recreate this yourself. So first off, we need to generate all the segments around the vertices around the segments. And as you can see in Unity, what we have now is this wire object. It contains of all these joints and sphere colliders. So let's generate some vertices. We need a function for generating the vertices, so let's create that. And inside this one, we will loop through all our segments. So creating a for loop for let's segment all the segments we have. Okay. For each segment, we will create this a circle around it where we will have all the vertices created. So let's generate a new method for that. No. Segments I. We will also send in the current index. So inside this one, we need to start by calculating. We have how many sides? Have we specified that? No, we have not. So let's do that. Radius. I think we can take this. Not a float. It should be an integer. Int sides. And let's go with 4 as default. The number of sides, since you only see 50%, you see when you render the the mesh, you will only see half of the mesh, of course. So going above 10 is kind of unnecessary. So let's keep it for 4 sides for now. It's easier to debug as well. So we need to start by calculating the angle between the different vertices along the circle, and we do that by creating a new angle diff. And that's since you have 360 degrees around the circle, let's divide it by sides, number of sides, and let's create a rotation from the center. So let's create a new quaternion. Diff rotation equals quaternion from rotation to rotation, and let's go from vector forward, vector 3 forward to the segment. All right, so this, sorry. Segment transform. And this is the segment index. Segment transform dot forward, because we need a direction. So this means that we will create a rotation. So now we need to loop through all sides. Current we have 4, but that could be different. So for each side, we'll create a side index. We will do this for as many as we have sides. For calculating the position of the point around a circle, there's a mathematical equation for that. Google it if you like, or maybe I put a equation explained somewhere on the screen maybe. But let's start with getting the angle in radians instead. So we need a new float, angle in rad, side index. So we have the current side angle diff. So that means that the first one will be on in zero angle, since this is 0, the first one. The second one will be 1 to multiply by the difference in angles. In this case, if we have 4, it will be 90 degrees, and then we need to multiply this with math degrees to radians. So we have the angle in radians instead. We need to calculate the x value, float x. This, just follow along with the radius times math and the cosinus of angle in radians. Then we have the float y is the radius times math and the sinus value of angles in radians. So now we have the x and y. So let's create a new point of offset, vector 3, point of offset, which is a new vector 3. You can describe it like this, x, y, and a 0. the set value. Here we need to create a vector 3 for the point rotated if rotation times point offset, and we need a value for point rotated at center of trans, which is the segment transform dot position plus the point rotated. So what have we done here? We created the new offset, a new vector 3 based on the new x and y value. We need to add the rotation, and we have the offset, which is the point offset from the center, and then we need to have the point at the center of the transform, which means that we need to add the position of the transform to the new point, the new location of the point that we have created. So let's see if we can render those. Let's store them into a new array of let's say vertices. Let's see if we can create a list for those. Oops, let's see. A list of list of vector 3. Let's add all those like this. This one should be rendered, or so let's go to let's add that on Gizmo draw, for each things in this one, count, sorry, Gizmo draw spare on and vertices index, and this size, let's go for 0.1. Let's see. Yeah, I already had this one. So let's move this code into this one. See what happens in Unity. Nothing. Let's see what's wrong. Yeah, looks like we didn't initiate this generate vertices. So let's go to our start function. No, we cannot use it there. We need to change update radius, update wire. Let's put it in here. See what happens. Let's go back into Unity. Bada bing. Loading. And we have a bunch of dots. They are not rotated correctly for some reason. They're all in straight line. Let's fix that. So the reason was this one. For let's go with the right rotation value instead. And let's see if we can update the position every time we on each render. Generate frames means we need to clear the temp. This one we need to clear that for each. Let's go back to Unity, see what happens. Cross your fingers, because I can't since I'm typing. Look at that. Now they're in a straight line again. That's strange. So let's see if we can, if that was only the initial value that caused this error. So back here again, let's change this forward again. Let's jump back to Unity. Let's see if it's only on the first render that it was causing the bad rotation. Loading, loading, loading. Yeah. So we have our vertices correct. Let's see if we can add sides. Yes. See that we get a bunch of more vertices along each. Let's see here. Get a bunch of sides. We don't need that many. Let's keep it for now. Good. Let's jump into visual. So we need to store our vertices in another way. So to do that, we need to create an array instead of a list, because this is arrays are faster as far as I know. So let's go into the start method. Let's create a new vertices. No, should be a new vector3 array. Which should be big as the segment count times the number of sides we have. And each side contains 3 vertices. Let's go for time 3. Let's create a new variable for this one. And inside here, let's add it to this one. Vertices. Let's add the vertex index. We haven't defined this yet, so let's do that soon. Point of transform. The vertex index is a int. Vertex index equals the segment index times how many sides we have. Plus side index. Okay. So now we can update this gizmo for looping all the vertices instead. Let's go up and remove this template vertices. Need to clear the, since we're overriding the vertices when we're generating the circle, we don't need to clear the array. Let's see if it's working in Unity. to render all the... Right, I need to save as well, right? Right, so we still have our vertex for all the segments, which is good. So what we need to do now is create a vertex indices map, which contains all the the reference to all the vertices indexes. Kind of a hard word for a Swedish guy to pronounce. So let's generate a new private function. If I can only spell correctly, private void generate indices map. Right. What should this do? This should create a new or update the vertex indices map, which is a property that we should populate with some things. Should create a new multi-dimensional array, which consists of the segment count times +1, but also the sides +1. Let's generate that. So this will contain all the indexes of all the sides and for all the vertices. Yep. Mesh vertex index. Let's start 0 plus, no. And for all x values in the segment, so let's call this count. So for each segment count, we'll go into all the sides for let's call this something else. Segment. So it's easier to understand. And this is side index. Side index plus sides. Okay, so we're looping through all the segments and then all the sides, and we'll add vertex index map, which is segment count and side index. Sorry, segment index. I can't write today. And this is the new value for this one. So let's increase that mesh index plus. So we have created the indices map. Good. So where do we call this? Yeah, well, we need to have a function called for generating the mesh once. So let's create generate mesh. We're not so let's create this inside there. We also need to generate inside the mesh. We need to generate the vertices. So let's do that as well. And then we need to figure out when and where we need to call this. So let's do that later. Let's take this one and we'll update it in here. If we're changing the radius, if we're updating the length, or changing the segments. We need little brackets as well, and also on the, let's do this on init as well. and this one is called inside there, so we can remove it from here. Okay. Let's see what else we need. We have the generate. We also need kind of update void update mesh. What do we need to do within this update? We don't need to create the new indices map, but we need to generate or update the vertices. Good for now. And now I think it's time to go through how to create the faces on the actual mesh geometry. So for that, I'm using a modified version of Sebastian Log's mesh data. If you don't follow Sebastian on YouTube, you should definitely check this out. I will leave a link in the comment because I really respect that. Sebastian, he's a really good developer, and I want to highlight his work. I follow his tutorials a bunch of times, both for fun and also for generating my own games eventually. So check his link, YouTube. He has a Git repository where he shares most of his code. Super generous. Yeah, so he had created this mesh data. I renamed it to mesh data rope, or wire, doesn't really matter. Modified it slightly, but basically it's you have a constructor for creating the basics, adding vertex, adding triangle. Triangle consists of three indexes, and each index reference a vertex. We have a calculation of the normals, depending if you're using flat shading or not. Yeah, if you want to know more about this generation, you can check Sebastian's channel, or just copy what I'm showing on the screen if you like. That's why I'm scrolling this slow. You can just slow down the time and rewrite it if you like. I've added this reset mesh, which basically takes all the values and just reset them, because if we're changing the number of triangles depending on sides and how many segments there are, we need to reset the mesh. So that's why I added this method. So let's try to use that. Yeah, so I will keep this simple. You can probably do it in a better way, but I will continue building on my generate circle vertices. I will rename this to generate circle vertices and faces. Okay. And inside this loop, we will have a if statement for if we should create faces as well, or triangles. Let's call it triangles. Create triangles. So if this is set, let's generate a Boolean field for that. We should do stuff, and we should not do it in the when we're updating the mesh, only when we're creating the new mesh. So inside here we should go with true. Let's start true, and when we're done, false. Okay, so when we're going into generate vertices via this way, we will generate the let's call it triangles instead. Okay, so we'll go into this one, and then we will run this code as well. And inside here we need to create a new we need to store the vertices somewhere. Let's create a new mesh data based on the mesh data rope that we created before, and we'll do that in let's create a new, let's go to the top, private mesh data rope mesh data, let's call it just mesh data, and this one should be instantiated inside the generating mesh. So right after here when we're creating the mesh, so if this is empty, mesh data, if this is null, then we'll need to create it. Mesh data should be new mesh data rope. We should have the number of vertices per circle, which is the same as the sides, number of sides. How many vertices along the rope should be segment count. And should we use flat shading? No, false. I want it smooth. And since we have segment counts, we have the starting and end, we need to add one as well to the segment, because we have an end piece as well. If it's already created, we need to update it, reset it to mesh data, reset mesh, the one that I implemented, and we will send how many, let's see, sides, also segment counts, plus one, and continue using, or don't use flat shading because I want it smooth. You can use it if you're doing a low poly style and you want the flat surface, you can just add true instead. Okay, so now we have the mesh data object. So let's add some vertices to this one. So down in when we create triangles, we should use this mesh data, add triangle. No, add vertices. Let's start with that. We need to add the, not this one, point of center, and we also need to create the new, this is the UV map. So new 0, 0. Okay. I will not go into the UV map for this one because it's a whole other story. And now we should let's see, we should create a new, this is for all, depending on which, if we should create a triangle or not. Let's determine that via a boolean. Create this layer, depending on the segment index, because if it's smaller than the smallest, we should not create the segment count at 1. So if it's below, if the segment index is lower than the max amount of segments minus done, then we should create a triangle, which means that if it's on the last segment or the last the end piece of the rope, we should not create any more triangles because there are no more vertices beyond that. So if create this triangle, yes, we need to have the incremental value, int current increment, let's say 1, how many steps we should have. we should create triangle A. Int A is from vertices in this map, segment index times side index. I will show you a short explanation of what I'm doing in a moment. Let's just create this first. Oops. In B, the next vertices is the index map, and we need to create the side index plus current increment. Then we have the last one, is not really the last one, but almost, segment index and side index current increment. And we have the last one, D. And this is the current increment. Yeah, so let me try to explain what A, B, C, and D stands for. Let's see if we can get this. I have a drawing here. Let's see if you can see it. There we go. So we have a segment piece of the things we're creating. So here's the first segment. It's going actually behind this drawing, but never mind. As you can see, down in this corner we have the indexes of 0, 5, 0, 0, 0, 1, 0, 2. And the second segment will get the indices of 1.1, 1.0, 1.1, 1.2, and so forth. And the A, B, and C we just generated is, okay, actually see, it's not in focus. Okay, so there. So we have A, B, C, D. And A is 0, 0, and we have an current increment of 1. B gets the value of 1, the segment count, comma, side number or side index. Then we have C, which is down here again. So 0, 1, and 1 and 1 for the D. And if you keep this image in mind, let's go back to the code. And you can see that we have the segment index of 1, or A is the segment index and side index, and then we increment it by 1. And for C, we increment the second variable with 1, and for the last one, D, we increment both with the current increment. Hope it makes sense. It took some time to figure this out, and also it helps to draw the mesh to get a good understanding of what each vertices are, and to calculate it correctly. Yep. So let's create a new variable called boolean is last gap, which means that it's the last one, meaning that it should not increment upwards. It should take the, when it's have done a full rotation around the mesh, it should pick the 0. Yeah, okay, so let's create it. Maybe it makes sense when you see the code. So if the side index is the same as the sides -1, which means that it's back to the beginning in the circle, we should if this last, then we should change C should not be incremented. It should be, let's see here, this value is the same. So instead of adding the incrementation, let's pick the first one. There we go. So we're on the same segment, but we're picking the first one in the lower. So when it's, I don't know if you can see. So if it's around, if it has come all the way around, it should pick the 0, and it should pick the 0 up here as well. So that means that the D should be we have current increment, which means that we are on the segment and one step above, but we will go back to the first segment, but also without incrementation. There we go. Then we need to add these two triangles, because each let's go back to the drawing. Each square, it consists of, it's super hard to point mirror wise, but this one consists of two triangles, as you can say. So each face is two triangles. So let's add those two. Mesh data. No. Mesh data. Small. Add triangle. A, B, B, and no. A, D, and C. And the second triangle should be B, A, and B. And why in this order, you may ask? Because this determines in which direction the normal of the face is pointing. So if you're generating this and you get the a mesh that is turned inside out or look really strange, try to rearrange the vertices that you're in the change the order of the vertices you're adding to the add triangle, because this determines which direction the normal is. Okay. Nice. So now we have added a bunch of triangles to this one. Let's see if we can render it somehow. So if we go up to the render, not the render, the generating of mesh, we need to add all those mesh data for Unity to know what to do. So yeah, let's start with inside here we have generated all the triangles. We need to process it. Mesh data, process mesh. We need to create a mesh. Mesh is mesh data create mesh. Okay, so we need to have a mesh variable for that as well. How do we get this to be shown in Unity? Let's jump into Unity and see. So to be able to, okay, so just hold on. Yeah, so I got a bunch of errors, and that was because Gizmo were trying to render, so I added this if it's not null, then render it, otherwise don't. So in Unity we need to add some components, mesh filter, we need to have a mesh renderer. We can leave this as this for now, and in the script we need to add those. So let's do that. Put them on the top. Serialize field, private mesh render and also a serialized field for mesh filter. Wait, whoops, that's it. Mesh filter. Okay. Good. So what do we do with those, you might ask? Let's do this in Unity. So let's go back here. Let's update this one, saving the file first. Okay. A bit of thinking. We should have the mesh renderer and mesh filter up here. So let's drag them. Mesh filter, mesh renderer, and they're empty right now because we will add those via script. But what we need to add is a material. So let's go to materials, create a simple shader, simple material, rope. I have rope. Let's do this. Let's call it wire instead then. Wire white. Wire. Let's change the base color to something like, I think blue. Blue is nice. Okay. The wire, let's add, which one did I have? This one, wire 1. Why? Okay. Wire, let's add it there. Okay. Inside the Visual Studio. Right, so we need to add the mesh to the mesh filter. So let's do that after we generated it in generate mesh. So here we have the mesh now. Mesh filter, shared mesh, mesh. Do we think that will work? Let's see. Let's save the file, go back to Unity, cross our fingers again. Yeah, we have a mesh, but it's not updating. And it looks kind of strange. So let's fix that. So inside Studio, let's get this mesh filter. We need to update the vertices. Mesh vertices should be updated with the value from that we stored in this one. Vertices. Will that work, you think? Let's see. In Unity, let's save the file again. See what happens. No, nothing. Why doesn't it work? I think I know. Let's pause. Let's jump into Studio again. We're not calling this one anywhere. So where should we call update mesh, you think? We should update this on every frame. So let's go into update, call it. Cross our fingers, jump back to Unity, save. Of course we did save. So Unity, we're reloading. Loading. Look at that. Let's remove all the gizmos. And voila! We have a squared rope. Let's see what happens if we change number of sides. Something strange happened. Yeah, cool. Uh, segment count. That seems to be working kind of okay. It's acting a bit strange, but I mean, let's see if it interacts with this as well. Yeah, cool. So let's see what's wrong with the sides, because this is not the expected behavior, right? Creating some kind of screw, corkscrew or something. Cool. What we didn't, what we missed is that we need to also, if you remember this, we only update the wire and the mesh generation if we change any of these properties. So let's do that for sides as well. So let's create a new previous sides equals sides. Okay, let's create a property for that. If sides is not the same as the previous sides, then we should do something. What should we do? I think we need to calculate how many vertices we have. Let's see, because we're changing the number of vertices. So vertices should be a new vector 3, which is the size of the segment count. Segment counts times sides times 3. Same as we did up here. What we should do more is generating a new mesh, right? Generate mesh. And then we're setting the previous sides as the current sides. Okay, so let's see if that solves an issue. Let's restart this corkscrew. We have 4 sides. That's nice. Good start. Let's increase that to 8. 8 sides. Wow. How many do you think we can have? 80. Yeah. We possibly could. Doesn't it feels really unnecessary, because like I mentioned previously, if you turn off and have only shading, you will not see any difference between 80 or 10, or maybe even lower. 5. Yeah, then you can start see the edges. 8. It feels like 8 is a good number to not show the direct. So what happened to my? Oh, there. Some kind of lag. That's how to generate the mesh for this rope. I hope you all like this, maybe learn something about mesh generation. It's a really cool thing to master, because once you learn the basic of the mesh generation, you can basically do a bunch of cool things with procedural positions of points and so on. Yeah, what else is there to say? I hope you like this, and make sure to subscribe so you don't miss the updates on my scheme game. I have done some progress. It's been a while since I posted anything about it, since yeah, summer happened, and also I have a life with family and vacation and so on. But yeah, I will try to do some work in this autumn as well, so you'll get some updates on the game. Thank you for watching and see you next time.